Okay, so welcome back, and today we're going to talk about doubling time. We've talked about it before, but now I'm going to go through the process just for completeness and basically review. So here's the model for the exponential curve, right? For the exponential growth and decay. And so now we're talking about growth model, so we know that k is going to be positive. And so we're talking about doubling time. So that means that we're talking about finding the amount of time that it takes to double an initial amount, to double a present value, right? So a sub I. So this means that we're going to have 2 times a naught. So this is the situation. So if we solve this for t, that will give us doubling time. So again, if we go through the process and we divide both sides by a naught, right? Then we get 2 equals e to the kt. And then again, we take the natural log of both sides. And again, we get what? We get the natural log of 2 equals k times t. And we end up with what? We end up with t equals the natural log of 2 over k. Now, notice that in this time, it's the natural log of 2, right? I mentioned that before. So our doubling time, which we can also call it capital D sub d, right? The doubling time is equal to the natural log of 2, okay? Some textbooks use this, but again, it's t, the amount of time it takes for the present amount or the initial amount to double is given by this formula. Okay, so now that we know that, we can also solve for k, right? So that means we can also use this to find the constant, which is going to be the natural log of 2 over the doubling time, right? Or t. Right, so you can also put t. But understand that this t, it's actually I'm going to put t sub d because again, it's the constant is based on the doubling time in this case. Okay. Okay, so let's do an example. So in this example here, it says, according to Moore's law, the doubling time for the number of transistors that can be put on a computer chip is approximately 2 years. Okay? Give the function that describes this behavior. So the doubling time, it's talking about the number of transistors that can be put on a computer chip is approximately 2 years. So now, from the formula, we can use, right? So now, we want to find the constant, right? So if the doubling time is 2 years, right? Oh, so we're going to use this formula here. So we've got this one and this one. So let's use this formula here. So the doubling time is approximately 2 years. So that means in this example, it's going to be, the constant's going to be the natural log of 2 divided by 2. And so now, if we go back to the model, we have a equals a naught e to the kt, where k is equal to this, right? So now we're going to say a is equal to a naught e. Now k is equal to the natural log of 2 over 2 times t. And that gives us our model. And so the function is, well, that's the function. Now we'd have to know more information. To, you know, obviously we don't know a naught, but again, our model would be that, and we're done. Have a great day.